So you found the skeleton. How would you tell people that this happened? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
All right. Well, hello, everyone, and welcome back to the show. We got a fun one for you today. So joining me is, of course, my host and co-host, Peter, who is, I believe, going to be off screen, but who's going to be on screen with me is the one and only Dapper the Dinosaur.
Hello.
The dapperest of dinosaurs.
That's me.
And we are also joined by Dr. Fazal Rana of Reasons to Believe. Welcome.
Yeah, thanks for having me. It's looking forward to the conversation.
It's been a little while since we had you on.
Yeah.
Let's see. I think last time I had you on, we had Colton, who was also talking with us. Or was it?
Yeah, I think that's right. Yeah, it was about dinosaur blood in the age of the Earth. Soft tissue.
Oh, you wrote a book about that, didn't you?
I did. Yeah, Dinosaur Blood in the Age of the Earth is the
right.
It's a really good book. Highly recommend.
Thank you.
I was rereading it, and RJ and I have an extensive section in Rocks Volume 2 where we talk about all of the young Earth creationist arguments about the various types of soft tissue, whether it's dinosaur soft tissue or quinones or chitin or what have you, all the different ones. So yeah. All right. Okay. Well, today we're going to be talking about information, and most likely in the context of biology. And as is typical for these conversations, that Dapper and I do, we give our guest the floor. So
yeah,
have at it.
Yeah, well, and again, I just want to say thanks, Jackson, for hosting this, and Dapper for the invitation to have the conversation. I'm looking forward to it. I usually learn quite a bit from these conversations, so I appreciate it. And I must admit, there's a bit of a dilemma here, because I actually do spend some time trying to convince my brothers and sisters in Christ who are young Earth creationists that humans and dinosaurs didn't coexist, and here I am having a conversation about information with a dinosaur. So,
well, look, I'm a special case, so don't worry about it too much.
So anyway, just a little bit of humor. All right. So what I'll do is I'll try to, be brief. I've kind of penciled out some comments I like to make to set the stage. So I would actually invite you, Jackson and Dapper, to jump in at any point, just so that I don't drone on too long here. But what I'm going to do with my opening presentation is, first of all, try to define what I mean when I use the term information, and what I really am interested in defending from my perspective as a Christian apologist, where my project is to make a case that biological systems are designed, right? And I'm going to approach this information conversation from an origin of life standpoint, because I'm a biochemist by training, right? And I've spent a lot of time thinking through and studying the origin of life question. And I realize that there's a whole another conversation we could have about, once we have life in place, how does biological information originate, through the history of life? And I'm okay to engage in that discussion. I'm just simply not going to approach it from that perspective, just so you understand where I'm coming from on this. And then once I kind of lay out what I mean by information, I'm going to just give a quick summary of how I make an argument for design, looking at information from a biochemical context. So that's how I'm going to structure it. So again, please feel free to jump in. I won't be offended or hurt or feeling, that I'm being treated unfairly if you interject or raise questions. And then after I get through my opening statement, we can have a lot of fun talking, if that's okay with you guys.
Yes, sir. Works for me.
Sounds like
okay.
It to me.
Okay, so when it comes to information, and I'm a biochemist, I'm not an information theorist, right? And, I've dabbled in information theory only as a really a novice reading, and then trying to use what little I know in the context of my project, which is to make a design argument. But the book that probably has had the biggest influence on me, I don't think you can see this, but it's called Information and the Origin of Life by Bernd Olaf Coopers. And it's a book probably published in the 90s, early 90s by MIT Press. And then another book that has been influential, again, a classic published in the 90s. This is Information Theory in Molecular
Hubert
Biology.
Yaki. I'm
Hubert
familiar
Yaki.
with Yaki. Yeah.
Yeah, so those are the two books that I've primarily have spent time in, and I've got a number of other books on my shelf on information theory, and it can become quite mathematical quite quickly,
Right.
And so I have a lot of respect for people that work in that area. But just so just all the disclaimers aside, so when it comes to information, I think most people would argue or agree that Carl Shannon was the father of modern day information theory when he was at Bell Labs, where he essentially argued that information could be understood as being a sequence of discrete symbols, right? And developed mathematical expressions to quantify the amount of information, in these discrete sequences. And the equations that he developed look very much like the equations from statistical mechanics for entropy, except the sign is negative instead of positive. And so he refers to information as entropy. And in a nutshell, his equations basically show that the more probable it is for a random sequence of information to be assembled by chance, the lower the information content, or conversely, as the probability of that sequence assembling by chance diminishes, the information content increases. So, the very useful concept, I think, if you're trying to understand how information degrades when you're transmitting, signals, which is, I think, what Shannon's project, at least initially, entailed. But for me as a biochemist, Shannon information is of limited value because you can have two, proteins that have different amino acid sequences, but would have the same information content. One of them could be functional and one could be a non-functional protein. And so, Cooper's, talks about the three dimensions of information, one of which is Shannon. The second layer is semantic, where this would now be the amino acid sequence for a protein that produces a functional protein, that a semantic information has some kind of meaning. And again, in a biochemical context, that would be a protein that would be functional. He also talks about pragmatic information, which to me seems very similar to semantic, and that is that it's information that has meaning, but then can elicit an action, some kind of goal-oriented behavior. And in effect, that's really what you talk about when you think about that protein now working in the context of a biochemical system. So, for me, if you're approaching information from a Shannon perspective, then in the biochemical context, you need to talk about pragmatic information. And I've seen people present ways to quantify semantic information and pragmatic information. I've not spent a lot of time really delving into the mathematics of it, but I've seen people make that type of an attempt, and maybe successfully. It's above my pay grade to evaluate whether those projects are useful and are successful. Now, another approach that I today find very interesting. 20 years ago, 25 years ago, I would have gone down the Shannon path or the Shannon-like path, looking at semantic and pragmatic information. But the approach that I think today is actually most reasonable from a biochemical perspective is thinking about information algorithmically. Now, Kuppers, in his classic work, has a whole section devoted to algorithmic information. And in a sequence context, when we're looking at a sequence, the algorithmic information is the complexity of the instructions needed to specify that sequence. So if it's a very simple set of instructions, like let's say you have polyalanine, that's 20 subunits long, you would say, add an A or an alanine, repeat, and then when that loop gets to 20, you stop that process. So those are relatively simple sets of instructions. And the most complex set of instructions would be essentially specifying the sequence itself in the instructions. And so that's how you can quantify information algorithmically. Now, there was a paper published in 2010 that changed the way that I think about information. And Jackson, I sent you a deck of slides. We don't need to look at all these slides, but
which slide would you like?
It's the very first one. Sorry about that. I should have specified. It's the very first one. This is published by Paul Davies and Sarah Walker, I think 2010, in the Proceedings of the Royal Society, the Interface Journal. So this is more looking at interdisciplinary ideas. And in this paper, they entitled The Algorithmic Origin of Life, they argue that the reason why origin of life researchers have failed to make any genuine progress in understanding the origin of life is that they're asking the wrong question. And of course, that's a grandiose statement to make, but that's Paul Davies. And his point is that really the origin of life question is a question about how do we account for information, the origin of information. But interestingly enough, he basically argues that, look, when we talk about Shannon type information, assembling an RNA molecule with a functional sequence is something that we could envision evolutionary processes doing. Now, I question that, and we can get into why I question that. But let's just grant Davies' point. But he says that's not the information that's of interest, really. It's the fact that there's instructions that are instantiated within the biomolecules themselves. That's algorithmic information that is describing how these molecules essentially function in a biochemical context. In other words, that it's algorithmic information, but it's instantiated in the molecular structures themselves. So very interesting idea. And I had this aha moment about a decade later, takes me a while sometimes, when a paper was published in Current Biology by a research team that was looking at the gating action of a single-celled organism. I think it's Euplotes is the organism. Okay. Jackson, you might know. But it's a single-celled organism that has these pseudopods that extend from the cell, that when it attaches to a surface, engages in gating action. And people that have studied this organism have commented over the years, it's almost as if this organism has a primitive nervous system. It seems to be able to process information from the environment. Well, it turns out that what these researchers discovered is that there's this microtubule network that's controlling the pseudopods, and that it's essentially functioning like a finite state machine. And I've got a slide there if you want to, just so that people can.
I think I'm familiar with not that organism specifically, but others that do similar stuff. Like there are a bunch of like ichthyosporians, filasterians, protists, unicellular eukaryotes that are very close to animals. They kind of switch between a flagellate stage and an amoeboid stage. So I'm kind of familiar with related things to that, not that instance specifically. What slide do you need?
It's the second one, if you don't mind. Thanks. But this is essentially what a diagram showing a finite state machine, and it's used a lot in software development. But there's actual mechanical computers that, believe it or not, are all around us that are finite state machines. And a finite state machine is a machine that can exist in discrete states that will transition from one state to the other depending on the input and the state that the system is currently in. So if you go to the next slide, a silly example, but it helps make the point more concretely, is a door is an example of a finite state machine. It's a mechanical computer. I don't think we would think about a door in that way, but it exists in two states, right? An open state and a closed state. And, depending on the door, that if it's closed and you push on it, that's the input, nothing happens. But if you pull on it, the door opens, it changes states, right? So that's an example of a finite state machine. And it's actually a mechanical computer because built into the structure of the door itself is the instructions, is the algorithm, if you will, that dictates the functioning of the door. And so the, vending machines, ATM machines, and the list goes on. These are all examples of finite state machines. So it's provocative because now you're arguing here that the information that you see is actually built into these biomolecules. And this is the point that Davies was making, whether he realized that what he was describing were finite state machines or not. So it's like, aha, now I get what Davies is really driving at. And so I've actually got a side project going with someone who is a retired engineer who spent his career working on finite state machines, where we're doing a project where we're exploring the possibility that, in effect, biochemical systems in their entirety are actually finite state machines. And that could be a really interesting way to begin to think about, about finite state machines. And so that is how I think about information is really algorithmic information that is essentially instantiated in biomolecules as finite state machines. Now, I don't know how you would go about characterizing that mathematically, but it's I think an intriguing idea that the more I think about it, the more I think that that's really the way to think about, again, biological information. And so, when you think about Shannon information, it's digital. And if you think about information that is built into the structure of biomolecules, it's, in a sense, in an analog format, you could argue. But there is that interplay between the digital information, the Shannon information, and, of course, the algorithmic information or the analog format for that information. So anyway, that's how I think about information. So, and then very quickly, the way that I advance the argument for design, and I think, Dapper, this is what you picked up on and were critical of, and that is, the assertion that I make that our common experience is that information comes from intelligent agency. And so the fact that when we look at biochemical systems, we see, essentially Shannon-like information in nucleic acids and in proteins, maybe even you could argue in oligosaccharides that are attached to proteins or to lipids. And then I point out that it's not just simply the Shannon-like nature of that information, but intriguingly, the information in biochemical systems is structured in a very similar way to human language. And this is a point that Coopers makes in his book and spends some time actually developing, which is intriguing because now it's not just a single watchmaker type analogy, but it's like a hierarchical analogy. And in fact, when biochemists treat biochemical systems as language systems, it oftentimes leads to some really profound insight into the structure and function of those systems. And then I go one step further and say, look, we also see codes that are organizing and really defining the information. And our experience, again, is codes are the product of intelligent agency. And then I go one step further and say, this is intriguing. This is an intriguing idea that the enzymes that manipulate DNA during DNA replication, DNA repair, transcription, and then even when you think about what's happening at translation, these are all biochemical Turing machines. And a Turing machine is an abstract machine that Alan Turing invented that forms the theoretical framework for computer science. And so the idea here is that when you see something like DNA replication, it literally is a computer operation. And in fact, that analogy is so stark that it's inspired this whole area in nanoscience called DNA computing, that is the brainchild of Leonard Adelman, a computer scientist at the University of Southern California. And what's happening with DNA computing, and I don't know if these are ever going to be practical computer type systems, but these are wet computers that are, that do the computation in test tubes, but it's built from DNA and the enzymes that manipulate DNA. And these are extremely powerful computer systems because of the massive parallel operations, and in fact, can solve problems that you can't solve with silicon-based supercomputer systems. But that again adds to that analogy. And then there's a paper that I saw that was published as a preprint by Kevin Mitchell, who's at Trinity University in Dublin, Ireland, and a computer scientist by the name of Nick Cheney at the University of Vermont, that argues that when you look at a genome, it's actually massively compressed information, and that during the course of development, the genome is in effect functioning as a generative AI system, which is a very intriguing idea. But again, it adds to the depth of the analogy. So, my point is that when you look at this hierarchical set of analogies, that the most reasonable explanation is that indeed biochemical systems must originate from the work of a mind in some way, that they reflect the work of a mind. So that's my argument in a nutshell, and that's how I define information. So now I'm ready for you guys to have at me.
First, Peter, can we go back to the 3 screens, please? There we go. Okay. Dapper, since you were, it was your idea, so I'll let you go first. Go ahead.
Well, so I really do appreciate a fairly clear definition for information. That's the first thing I want to say, because as I'm sure Jackson can back me up on, getting someone who has any issues with the theory of evolution to define information at all is usually like pulling teeth from an angry boar. It's virtually impossible. So I do appreciate that. So the tweet that started this whole thing, and yeah, I'm still going to call them tweets. Sorry, Musk. If I remember correctly, because I don't have it handy, and I'm not sure where it went, but basically you had said something like, only human minds are something that we experience creating information. And given the information, or the definition for information and the various nuanced things that you had said, I still find that to be a very, very odd, and I would say obviously incorrect assertion, because it seems to me like this kind of information, specifying products that do things in biochemical systems that then have interactions with, that organism's environment, are something that we see arising spontaneously, or at least we see very conclusive evidence of it having arisen spontaneously in the real world in biological organisms fairly routinely. I mean, any species-specific orphan gene is going to be an example of that, unless you want to claim species-level special creation, which, as far as I know, you do not. Also, the fact is that genetic algorithms do this all the time, and if your objection to that, which is a common one that I hear, is that, will humans set those up? Okay, but that just means that you're rejecting the possibility of experiment overall, which I also don't think you're doing. So to me, it still seems like, under this definition, you have not given sufficient grounds to say that only minds can create this information, whether we want to talk about it algorithmically, or in terms of Shannon information, or in terms of semantic information. And then as a bit of a side note, I am always suspicious of linguistic comparisons to biological functions other than language, because I find that when you dig into them, most of the people making them are, I'll say, extremely naive about what languages are and how they function.
I think we'll go with the direction that Dapper's going. I was gonna go more with the I never really like referring to organelles and cell parts as machines. There's a series of papers that talk about the issues with the analogy, mostly because there's a large degree of stochasticity with cellular machines, things like that. But I'd rather stick with. I won't derail us. I'd like to stick with the point Dapper made. So, okay. So, hand it back to you, Dr. Rana.
Yeah, and I appreciate that. And just to be clear, sometimes when things are tweeted, there's a bit of exaggeration just to create things that are provocative. And so, I'm actually sympathetic to your point. And again, I'm thinking about this in the context of the origin of life at this juncture. I'm not thinking about it in terms of the history of life. So how do you account for the generation of information, initially, if you will, in an origin of life context? And I think you could make an argument, this is the point Davies makes, that evolutionary processes, at least in principle, can generate functional biomolecules from random sequences. That this is what you see happening, in hundreds of times in papers published involving in vitro evolution, looking at RNA molecules where people are evolving ribozymes. Now, I would argue that when you look at what is required for that in vitro evolution of RNA molecules, it's essentially a mechanistic process in the lab that would have virtually no bearing on the origin of life question, because it's involving, basically, DNA polymerase, and it's involving reverse transcriptase. Sorry, I was drawing a blank on the name of the enzyme, right? So it's a highly contrived system in the lab that would be irrelevant for the conditions on the early Earth, right?
Okay,
and in fact, and so nobody really knows, how you're going to generate that kind. You can potentially assemble an RNA molecule on a clay surface or some kind of mineral surface, but once you have that, how you generate, a population of RNA molecules that undergo selection is conceptually, you could come up with scenarios, but realistically, I question if those are reasonable scenarios. So, but granted, let's just grant, for the sake of argument, that you can generate, as Davey says, Shannon-like information in RNA molecules. I don't know that there is, and this is Davey's point, that there's actually an understanding of how algorithmic information would get instantiated within biomolecules in such a way that you see that algorithmic information being integrated in the totality of a biochemical system. Okay, so perhaps it is a God of the gaps, but my argument isn't a God of the gaps argument. It's a Watchmaker argument where, you have to admit that one source of information is intelligent agency at minimum.
Yeah, I don't think anyone would deny that intelligent agents can create algorithmic information, as you described earlier. I do want to make sure that I'm understanding you. And so I had come into this perhaps mistakenly thinking, on the basis of what I inferred from your tweet, that you were saying that under no circumstances can minds make information as you're talking about it. And it seems like at this point you are not quite saying that. You were saying that we don't have a mechanism for generating this at a certain point in the history of the development of life on Earth, but that afterwards perhaps we do. And that because like I said, I don't remember the tweet exactly. The way I came into this was thinking that you were saying that there was no mindful, if we want to use that word, way to create information. So, okay, now that I know that that's not what you're saying. And
to be fair, I mean, my tweet strongly gave that impression.
Okay, fair enough. Well, that makes me feel better.
It was a tweet. So
I'm not going to hold everyone to everything they ever tweet, because, geez, would I not want to be held to that standard? So I'm not going to hold you to that. So I appreciate that, because that does help clarify things for me. So I want to make sure that I understand which parts of the kind of story of the history of life that we're getting from the consensus of science that you might have a problem with. So do you think that this precludes universal common ancestry in any way? Do you think that the idea of all modern cellular life evolving from a single cellular ancestor without a mind is possible under your definition and your ideas about how information can and can't come about?
Yeah, that's a great clarifying question. I would hold to limited common ancestry. So I would reject universal common ancestry, or I would maybe reject isn't. I'm suspect that that evolutionary processes can fully account for the totality of the history of life. I think there are key transitions in life's history where it looks as if there needs to be the input of intelligent agency. Right?
And do you think that because you think that there's a problem with the information generation capacity of evolutionary mechanisms?
Maybe I should have, but I've never thought about it, in that sense, right?
Yeah, that's fine. Yeah, that's understandable.
I mean, I've never thought of it in those terms. And I want to be kind here, but I think there are some things that well-meaning Christian apologists say when it comes to the information in biological and biochemical systems that are misguided. Let me just say that are misguided. I mean, this idea
get me disagreeing with that statement.
Well, and like the idea that evolutionary mechanisms can't generate new information, all it takes is to look at, the hemoglobin, right?
That's a great example. Yeah.
Right.
I did a whole video on that.
That causes, that the mutation that causes sickle cell anemia. Well, in one context, you could say, well, it's a degradation of information, but in the larger context, when people are exposed to the malaria parasite, it actually offers an advantage.
Oh, I was thinking you meant in the context of like the evolution of hemoglobin, like how it's like repeatedly duplicated, and it was like cytoglobin and myoglobin and neuroglobin.
Yeah. No, I'm just thinking very in terms of.
Gotcha.
Yeah. So you could argue, and this is where the idea of semantic and pragmatic information becomes really important, is that semantically and pragmatically, that mutation in certain contexts is an advantage, right? So yes, indeed, sickle cell anemia is a horrible disease, but if it prevents you from dying from the malaria parasite, that mutation is going to,
right?
In certain parts of the world is going to. So
yeah, it's very prominent in India and sub-Saharan Africa for that reason, because those areas in the world are the places with the most malaria.
Right. Well, but to Jackson's point, at least conceptually, the idea that you can get gene duplication, or at least duplication of regions of the genome, and then they can diversify. Those are valid mechanisms that could generate information, right? So I'm not comfortable saying that evolutionary processes cannot generate information, right? And even this in vitro RNA experiment that we're talking about, right? That is a situation where a type of Darwinian process, if you call it that, is generating information. To me, my criticism of that work and people, that have done that work, like Gerald Joyce at UCSD. I mean, it's just, it's very impressive work,
right?
That you have to admire, regardless of your worldview. But I just think that the scenario in which in vitro evolution is taking place in the lab is irrelevant for the origin of life process. Now, it doesn't. But
I mean, it's only one part of it, right? It's not, it is just one tiny step in,
right?
A long chain. Yeah.
So the thing that concerns me about the lab thing is that this is actually similar to something I do encounter a lot, which is a rejection of a laboratory experiment on the grounds that it does not adequately reflect what happens in the real world. But the problem is that is kind of the point of a laboratory experiment, right? The point of a laboratory experiment is to get rid of as many variables that you can't control as possible. in order to test for the very specific thing that you are testing for. So for instance, if I want to test for, can RNA strands catalyze their own replication, whether it be, like in a two-state thing where like you make the conjugate of the RNA strand and then that conjugate makes the original RNA strand and back and forth, ultimately making more copies, or whether it be in some other form of way like making an enzyme, because we know that RNA can, form their own enzymes that just directly enhances the replication, whatever. If that's my experiment and I demonstrate that that's the case, I feel like I've demonstrated, one, that RNA can reproduce on its own, and two, that it's therefore going to be, susceptible to various evolutionary mechanisms. And the state that, like, well, it's in a lab, yeah, that's kind of the point. I'm testing one specific thing. And it just seems to me like if we're going to reject it for that reason, we're just going to have to reject the idea of experimentation in the first place, because that's all experiments. Like, we don't say that, oh, you can't test that, experiment that you did to test this, force of gravity by dropping a ball off of a table and then another layer ball off of the same table and seeing that they hit the ground at the same level or the same point, because you did that in a sterile environment. That's not how it works out in the world. Like, well, yeah, that's the point. I need to be able to eliminate as many extraneous variables as possible. So why is it that this is a problem for this? Because if I wanted to be uncharitable, I would say, I think you're saying this because it's just something that disagrees with what you would prefer to be true. But I would rather not have to come to that conclusion. So I'm just hoping that there's a really good reason as to why this laboratory experiment is not acceptable.
Yeah. Well, I wrote a book where I advanced this argument called Creating Life in the Lab. It was published in 2011, which just seems like yesterday to me.
How time flies, right?
Yeah, it's 13 years ago.
Yeah, I know the feeling.
I'm getting to be an old crotchety guy, but which is kind of fun, actually, being old and crotchety at times. But anyway, to your point, Dapper, which is a really fine point. In the book, I point out that when an origin of life researcher is in the lab looking at some kind of prebiotic reaction, there's really three goals that they have in that laboratory work. The first is what we'd call proof of principle. So if we look at, in vitro evolution of functional RNA molecules, that's a proof of principle experiment, to be fair to Gerald Joyce and others that have done that work, right? That you're just simply asking the question, can evolutionary mechanisms generate, functional RNA molecules? And what is the range of functional molecules that can be produced, as ribozymes? So as proof of principle, that's a successful experiment. The next, goal would be understanding mechanistically how that process works. And this is perhaps in the in vitro RNA experiment is not of primary interest, but let's say you're trying to understand how RNA building blocks, would form, and you're let's take the Sunderland reaction, that where you can have a 5-step synthesis of ribonucleotides, at least certain ribonucleotides, in a laboratory. So part of that work is going to be understanding mechanistically how it happens. In both of those examples, what I would call researcher involvement is absolutely indispensable. In fact, it's preferred because you want to be able to manipulate and control the system in order to gain, ultimate, as much understanding as you can about what's going on. The third criteria for an origin of life researcher is demonstrating geochemical relevance. And that's where I think the work in prebiotic chemistry breaks down, is that, because now the control that the origin of life researcher is exerting on that system that's necessary for proof of principle and for mechanistic understanding is now actually a problem, right? Because if that involvement becomes too extensive, that researcher is actually involved themselves in the experimental design unwittingly. Now, and so therefore, when you look at the in vitro RNA experiment, it meets the criterion of proof of principle, and you can even argue maybe mechanistically, but The question is it geochemically relevant? And the answer is no. Therefore, it's not relevant to the origin of life. And in fact, my argument is going one step further, is that when that involvement becomes extensive, what you're doing is you're actually arguing that that intelligent agency now has become a critical component in the success of the experiment. And so in Simon Conway Morris in his book, it's the book on convergence, Life Solution. Makes this very point that look, a lot of the work in prebiotic chemistry is so unrealistic that the hand of the researcher becomes, as Conway Morris says, for all intents and purposes, the hand of God. Well, in 2018, an origin of life researcher from Germany named Clemens Reichert published a perspectives piece in Nature Communications where he literally is making the same point that I made in 2011 in Creating Life in the Lab, where he says unwarranted researcher involvement is the Achilles heel, in effect, of origin of life research. And he has a parenthetical statement, interestingly enough, in the perspectives where he says, none of us are comfortable with the idea of divine involvement. So I think that critique that I'm bringing to the table is actually a valid critique, because independently, people that have a very different worldview than I, or at least a very different perspective on chemical evolution, because I don't sure Conway Morris, though he's a theist, would actually reject the notion of chemical evolution, nevertheless are reaching a similar conclusion or see the argument in the same way. I've just converted that into an argument for design. So that would be my response to your question is, researchers have to be involved to do experiments, and they have to be done artificially. But then it's how do you extrapolate that insight into the natural world? So dropping a ball in a lab under sterile conditions does actually translate into the real world. I'm not sure.
Can I ask a question about this?
Yeah, sure. Please go ahead.
So a question in my mind, one I don't think I've ever asked before, relating to this topic would be how do we quantify when there has been too much researcher involvement, for instance? So like, are there any, I'm not aware of any experiment, or at least I've never seen anyone talk about experiments where like someone does something like this, some sort of geochemical analysis or biochemical experiment or something like that, and then compares it to like, how does this occur in the real world? And then how can we quantify the difference between them? Does that make any sense? I've never seen anyone attempt to really quantify that, which is kind of why I'm also always a little always skeptical, I guess, or maybe not even skeptical is the right word. I'm like
Wary.
Aware, yeah, I'm wary of the that sort of argument that there's too much involvement. And I mean, I'm not saying there can't be, right? Because it's a whole it's like a dilemma in like philosophy of science, right? Like, how much can you study a system without contributing to it, right? I mean, that's a whole like discussion unto itself. And so that sort of question occurs to me, and I've never asked that before. I'm not really aware of what the research is. Do you have any idea on that?
Yeah, and I'd be interested in Dapper's perspective on this. I mean, you're asking the right question, and in my mind, what I'm seeing happen, at least from an armchair perspective, with regard to work in prebiotic chemistry, is more and more origin of life researchers are now acutely aware of the role they could inadvertently play in the success of an experiment. But I don't know how you would actually quantify that. And in a sense, it's highly subjective, to be frank. Is that because you could argue under some circumstances, that researcher involvement is minimal. In other circumstances, you could say, well, maybe it's crossed the line. But how do you define where that line is a legitimate question. That's a legitimate pushback. But I still think that there are points where you can intuitively look at an experimental design and say, okay, maybe we really have crossed the line here.
It's the meme, like, drawing on the chalkboard, doing the math equation, and then a miracle occurs, like that one, that sort of thing. Yeah.
Yeah. So, but I mean, it's a fair question, right?
Yeah.
And again, some of it has to do with what is your objective
Mm.
when you do that experiment. So, if your objective is, what kind of ribozymes can exist,
Mhm.
and is it possible for evolutionary mechanisms to generate them? I mean, those are legitimate questions that, again, are satisfied by the work of people like Gerald Joyce, right? But then if I ask the question, well, is what you've done in the lab relevant to the origin of life? I think even probably Gerald Joyce would say, at least directly speaking, the answer is no. Now you'd have to contrive some kind of scenarios on the early Earth that would
Mm.
analogous to what Gerald Joyce has done in the lab.
Isn't that why some researchers are doing experiments with like hot springs, for instance? Like they'll take like the sort of relevant biochemical materials and then they'll do the experiment in the hot spring to try to mitigate that sort of interference, I guess you would say.
Yeah. Well, and what I'm seeing people beginning to do are what are called Beilstein experiments. I don't know if any of you had the pleasure of
Tell us about it.
Organic chemistry, but Beilstein's is.
I've had organic chemistry. It's been a while.
But it's this massive compendium listing, in effect, everything that's known about every organic molecule in the world. And
that sounds like a big database right there.
Yeah, it's like about 14 million entries or something. When I was a chemistry undergraduate student, we had to take a chemistry informations class where we'd learn how to go into the library and look up things in Beilstein's and like half the library, the reference section was Beilstein's. Nice. And now it's all online.
Right.
But the idea is that you're essentially throwing everything you can into the pot, right? And you're running reactions and you're trying to then see if in that complexity there is some kind of self-organization that emerges. And so we're just now having analytical techniques and the computer power to really begin to analyze that the data from those kinds of experiments. But the late great Stanley Miller called for those kinds of experiments. Actually, that's the way we're going to really understand the origin of life. And people do these, laboratory simulation studies, to try to see what happens when you have these complex mixtures that would begin with reasonable materials that would likely exist on the early Earth. And so that's the way forward, I think, if you're really, for origin of life research.
So I have a question. What I'm hearing are a lot of, granted, I'm not an expert on any of the origin of life stuff, so I'm coming at this from a very much an armchair position, including these very nice armchairs I have, or chair arms I have here. But so what I'm hearing are a lot of objections to optimism about already completed experiments and skepticism as to currently proposed mechanisms, which I think actually is pretty fair. I think that from what I've heard, I think there are a lot of reasonably good criticisms as to, various current experiments in origin of life science, which, to be fair, it's a fairly young science. So, it's still, I think, trying to find its feet a little bit in terms of exactly what the right methodologies are. And, we're still finding its footing there. But what you had said earlier was you didn't think it was possible for this to happen without a mind. And what I'm hearing are reasons why you don't think current explanations are good explanations, which is okay, fair. But they're not currently being a good explanation for A is not the same thing as therefore A is impossible. So, and you said earlier that you didn't think you were trying not to do an argument from ignorance or a god of the gaps, but it does seem like that's what's happening. And so in what way would you say that that's not what's happening? Because just saying, well, I don't think the current explanations work doesn't get me to therefore no explanation logically can work, which is what I thought you were trying to argue for.
Right. Yeah. And fair enough. Fair question. And so, I'm, rare among Christian apologists, but I actually like the Watchmaker argument that Paley advanced. And so
I think you're in. There's a lot of company with you on that one. I think.
what's that?
Yeah, I feel like that doesn't make you rare.
No, I feel like that one's pretty common. Yeah.
Okay. Well,
at least in the circles that Dapper and I travel, anyway.
Yeah. Well, the thing is, because the Watchmaker argument has been criticized, and the two primary criticisms are the Humean criticism and then kind of a Darwinian criticism, if you want to categorize them that way. A lot of times people are making Watchmaker arguments, but they don't want to acknowledge it. They backpedal, but away from that owning it. So, in my book, The Cell's Design, I present what I would call a revitalized Watchmaker argument. But in a Watchmaker argument, you're basically making the case that, look, from our experience, we know this is what intelligent agents do. When we look at, in this case, biochemical systems, we see the same types of things that intelligent agents do. Therefore, we would include intelligent agency as the explanation, right? And there's a difference between saying, well, there's a intelligent agency is the ultimate explanation versus the mode of divine action. Those are actually two separate questions, right? And so when I'm making the argument for design, looking at information, I'm making a Watchmaker argument, and it's a multi-tiered hierarchical argument where I point out, all these different facets or features of, biochemical information that independently is the type of thing we would expect minds to do, right? Now, of course, the rebuttal then becomes, well, it's the rebuttal that you're raising. Well, is it really true that only minds can produce information? That's kind of a Darwinian rebuttal.
And which I thought we'd already established the answer to that question was no.
Right. Well, and I would say that it's, for Shannon-like information, I think you could make an argument that indeed, evolutionary processes could generate the information. My point is, for algorithmic information, I don't think we can make that argument. I don't think we can say there is a natural process explanation. I mean, this is the point that, as I understand the paper that Davies and Walker wrote, this is their point, is that this is the explanation for the origin of life. And we don't have an explanation for how finite state machines, in effect, could originate through some kind of evolutionary mechanism. Doesn't mean that they may not exist. Davies would argue that somehow there has to be an explanation because he holds to a materialistic perspective, as far as I understand Davies' views.
All right, so I think maybe I've misunderstood again, because I had thought that earlier when I pointed out that things like genetic algorithms and very taxonomically restricted, like down to the species level genes, the fact that these things exist and can be observed being formed anew, and there's conclusive evidence of their relatively recent formation, just the fact that they're species specific in the case of orphan genes, that right there constitutes evidence of algorithmic information being generated in a process that does not require a mind, and usually doesn't have a mind operating that we can find. And so now I'm hearing you saying that no, algorithmic information can't be generated in such processes. And so now I'm back to, okay, well then, how do you would you say that things like the antifreeze protein in nodothenioid icefish, which is a fairly famous taxonomically restricted gene that we know the full history of, does that not have an algorithmic information content? How do you know?
Yeah. No, I see your point. And I would apologize for not being clear, because as I mentioned, my project is in the context of the origin of life. So the question is, how do you account for the origin of algorithmic information, in a sense, de novo, right? Once you have that algorithmic information, I think it's possible to vary it under some kind of selection and generate variations of that algorithmic information, or maybe even novel algorithmic information. But it's how do you get to that point where there's algorithmic information to begin with?
Well,
So-
I mean, I would think that genetic algorithms would be an example in that the initial starting code is usually completely randomized. So there's not likely to be any particular algorithmic information at the outset unless you happen to randomly stumble upon a part of your sequence space that happens to be functional, which is possible and it does happen, but generally it doesn't in genetic algorithms, and yet they still manage to generate relatively complex algorithmic data information from what I can tell. And so it just seems to me like we're vacillating a little bit whether or not a mind is needed for algorithmic information at all, or if it's only needed for initial algorithmic information, or if maybe there's some reason why it just specifically in the context of the origin of life, it doesn't work. And so it seems to me like I'm not getting a clear picture of when this is a problem and when it's not. And to me, it seems like it's a little inconsistent. But I mean, I don't think that that's what's happening. I feel like I'm probably misunderstanding.
Well, and I may not be clear, but so in other words, I'm making my argument strictly in the context of the origin of life question. So
Okay.
I'm not making the argument once you have life present. So once we have the hypothetical last universal common ancestor, I'm not making my argument there. I'm making my argument in a sense in a origin of life context.
Right. But wouldn't the possibility of generating, without starting with any algorithmic information in a way that is analogous to evolution, which we know, at least in principle, prebiotic chemical systems can be subject to, wouldn't that on its own mean that the claim that it's impossible to generate algorithmic information naturalistically seem to have failed, at least prima facie? Like you would have to go pretty far in depth to show that that is not a reasonable example of starting with no algorithmic information in a system and then having it being generated in a way that we know can at least in principle apply to various biomolecules like RNA.
Yeah, that's an interesting challenge that you're raising.
Thanks.
And I would have to think about that, to be fair.
That's fair. Yeah.
But it seems to me, and I'd be interested in your response and Jackson's response, of course, is are you somehow slipping or are you somehow incorporating I guess I would say design or information into the process itself by which you are generating that information through some kind of genetic
I need to design things like a random number generator. I mean, that needs to be generated. I need to generate some kind of selection mechanism, but that's the kind of thing that is just minimal to experiments, right? You need to come up with a way to simulate the thing that you're trying to investigate. And so I would say that other than what is just minimally acceptable for experiments broadly, the answer would be no, right? I'm starting with, so like there's various versions of genetic algorithms, right? Like, so for instance, NASA has actually used them to design antennae that are going to go fly around Saturn and Jupiter, because regular antennae have too much interference from the ionizing radiation that's very common in that area. And so they've used genetic algorithms to generate antenna shapes that will be more reliable in those environments. And they just basically start with randomized shapes, a simulation of how radiation affects radio antennae, and then a system for saying which ones are best out of these randomly generated shapes. And then from there, they go on. So I guess you could say that in that case, well, they're designing the idea of radiation into it, but that's mimicking a real world thing. And I guess you could say they're designing the idea of an antenna, but again, it's mimicking a real world thing. And if you wanted to go about this and do it in a much more biologically relevant way, there are people who are doing that too, creating life simulations in which rather than simulating the effects of radiation on an antenna, they're doing things like simulating things like food availability, temperature, water availability, the energy involved in reproduction and things like that, sensory inputs and outputs, and the ability to evolve new ones, and evolving neural nets to control movement of artificial organisms. And in those cases, I would say, no, you can start with just completely randomized code. And yeah, sure, most of your completely randomized code is not going to do anything, but some of it will. And we can see that happen. And when you start with just complete random numbers, I don't think that the fact that the random number table is designed, or that the program itself is designed, is a problem. So for instance, you could say, well, okay, that shows that you need a mind to create the background that this algorithmic information is going to be generated in which case I would say, well, okay, but that's an argument for general creation in a very broad sense, but it's not an argument that life needed to have a special miraculous origin, which, by the way, I'm not like philosophically opposed to a supernatural origin for life. I'm just currently unconvinced by the various arguments put forth for it. I don't like, if someone could show me like, oh, hey, no, an omnipotent creator is absolutely necessary for life, I'd say, well, okay, I guess there's a God, and that's pretty cool to know. Seems useful to know that. But like,
yeah, and I probably need to go away and think about this, and that's the value in my mind of having these kind of
and I
conversations.
do apologize. I forgot to ask in advance how long you wanted to go. I didn't know if you want to just go for an hour, because we've been at it for about an hour now. I didn't know.
I'm fine to go for as long as you guys. I mean,
It's
maybe
really-
another 30 minutes to an hour, if that's not too much for you guys.
Yeah, it's fine by me.
Yeah, no, that's fine. That's how long this show usually goes.
Yeah, an hour and a half, 2 hours is a pretty typical
I don't
amount
want
for me.
to impose on your
Not
time.
much beyond 2 hours. I'm too old for that.
Oh, come on, I'm like 150 million years old, and I'm still doing 2-hour streams.
There we go.
So yeah, it just seems to me like there's a lot of counterexamples that, while not being the direct answer to a genetic generation of algorithmic data, at least seem to show that there's no currently viable logical preclusion to a non-mind mechanism for generating this kind of information. Which, and I know that in the chat people have asked about whether or not we can realistically quantify algorithmic data, but I'm satisfied that we can at the very least have a yes-no test for it and say it either does or doesn't exist in a particular system, and that is enough to at least start off with, right? Because you're not making the argument that like, oh, well, mutation can't increase algorithmic data. You seem to be okay with that. So I don't feel like it's necessary to say like, well, do we have an exact way to measure it? I'm fine with saying we can answer a yes, no, it does or doesn't exist. And my big point is saying, well, we have known mechanisms for generating it out of non-algorithmic data. In fact, actually, even with that ice antifreeze protein, in the ice fish that I mentioned, we know it was actually generated from broken copies of a pancreatic enzyme. So basically, it was Jackson, help me out. I can't remember the trypsinogen. Was it
Trypsinogen.
Yeah. So it was partial copies of a trypsinogen gene that then were neo-functionalized. So it was not
like
actually
3 amino acids, threonine, alanine, yeah.
Right. So basically, this trypsinogen gene was partially copied, which meant that destroyed it having algorithmic data because it could no longer interact in any meaningful way in the cell. In fact, I don't even think it had an open reading frame, so I don't believe it could even actually be transcribed fully. And so subsequent mutations took what was essentially completely inert DNA, and it eventually ended up with a fairly effective antifreeze protein that exists in the bloodstream of these ice fish, allowing them, in a very small group of these relatively widely distributed fish, to invade the coldest parts of the Antarctic Ocean that their very closely related sister species cannot enter because it's too cold for them, even though they're called ice fish. Because it turns out there's ice, and then there's the depths of the far Antarctic Ocean kind of ice.
Yeah.
So yeah.
So in let me step back and look at this now kind of in big picture terms, because again, my project is, can you make a case, for design from biochemistry? Again, and so the approach that I take is, again, a watchmaker argument. And I'm looking at this, again, from an origin of life perspective, because that's my training is in biochemistry. I did my degree in a chemistry department. So I think about biochemistry from a chemical perspective. So, that's the approach that I'm taking. And with a watchmaker argument, what you're doing is you're saying, look, this is what we see from that in terms of what human beings do when we create, when we design, when we invent, and we actually see those qualities when we look at biochemical systems. And as I outlined, when it comes to information, we see again this hierarchical structure to the information argument using again a watchmaker type of reasoning. And so on that basis alone, it's not unreasonable to think, well, that the origin of life, or in the fundamental design of biochemical systems, is coming from an intelligent agent. We would argue, it's the God of the Bible, but it's coming from an intelligent agent. So it's at least a rational, reasonable conclusion to draw. And again, when we look at, the evolutionary explanations for the genesis of biochemical systems and hence the origin of life, this is where things fall short, right? There's not explanation. So on the basis of these two, these two observations, I think it's reasonable to argue that there, at least for the origin of life, appears to be a creator. Now, as you're pointing out, what weakens the argument is that are there potentially natural process or materialistic or mechanistic explanations that can account for that information, whether it's Shannon or algorithmic? And I think what you've done is raise the question, perhaps, right? Perhaps the argument is undermined or in that sense, but it doesn't necessarily mean that the conclusion isn't reasonable to think that there's still intelligent agency, because now you could get into questions about the mode of divine action, right? Is God creating through some kind of mechanistic process, or is God creating, through some kind of process that's outside the laws of nature? So I think my argument is weakened. I don't think it's completely undermined. But
well, see, I don't actually think that it is, at least currently, something that could be ruled out, that there's an intelligence necessary or that was in fact involved in the origin of life. I wouldn't make the claim that that is precluded. But what I'm saying is it's not a reasonable conclusion, right? And it seems like you're saying that that is your conclusion, is that that is in fact the case. And my pushback is just to say, well, no, that's not a conclusion that we can warrant. That's just a possibility that we can hold open, and we would still need to have positive evidence for it. And all I'm seeing so far is that there is not currently enough. I just lost exactly what I wanted to say. I'm sorry. That because we don't currently have enough of a non-mind involved mechanism, that you're going to default to that. And I don't think that's appropriate. Because the thing is, like, I do think that the origin of life is very much an open question. And I am not hugely optimistic that we're going to find anytime soon, a solution to some of the various problems in there. And it is definitely the case that I do think that you could solve some of them if you had someone manipulating things, but I also don't think we have any evidence to support that. And just the fact that it remains an open possibility isn't enough for me to say that therefore we can make that conclusion. And further, I don't know how we could even start to investigate or test that. And until we do, we certainly don't have warrants to base experiments on it, because what would the experiment be? Yeah. I don't think there are any. And so what I'm seeing is I'm being asked to say that the scientific options, which are currently incomplete and I would say very wanting, but that still are under investigation, are not worth investigating or are just going to not be fruitful. And instead, we should take seriously an idea in which I can't even imagine how to begin investigating it. So to me, if you want to make there has to be an intelligence behind the origin of life on Earth argument, at the very least, you have to be able to come up with an experiment. Do you have an experiment that could possibly give positive indication of the involvement of an intelligence being involved in the origin of life?
Yeah, well, I would, the short answer to that question is I would say the last 70 years of work in prebiotic chemistry provides empirical evidence for that. And your question is an interesting question, and I don't want to drone on here about this too much, but we at Reasons to Believe we've got a scholar community. These are people that work with us as volunteers in different disciplines of science and theology and philosophy. And there's two friends, a guy named Dan Dyke, who's an Old Testament scholar, and a physicist named Hugh Henry, that a number of years ago wrote a series of articles for us on a concept that they call hypernaturalism, which is very interesting. So this is a bit of theology here. And so what they argue in a nutshell is that, look, when they coined a term supernaturalism, that, they argue that it's wrong in general to think of God working supernaturally outside the laws of nature when he brings about his creative purposes, because their point is like, why would God create laws of nature and then violate them every time he created? That, in other words, we would expect supernatural actions on the part of God to be relatively few and far between. But rather they argue that perhaps God is working hypernaturally, in which he's working through the laws of nature, but you could recognize miracles, if you will, by the just right event happening at the just right time with the just right magnitude. And then they go through scripture and they point out a number of places where God is performing miracles, but the miracles are hypernatural, where there's no laws of nature that are being violated. And so in light of that concept of hypernaturalism, I collaborated with Hugh Henry and Dan Dyke, and we wrote a paper where we argued that when you think about the origin of life, what is really happening could be understood as being hypernatural. And so, for example, when human beings manipulate the laws of nature to create technology or to affect things, we're functioning hypernaturally. When an organic chemist goes in the lab and runs a reaction and produces a new molecule that's not found in nature, they're not doing that in a supernatural way. They're doing it hypernaturally, where you are controlling the laws of nature and using them to affect an outcome.
Okay.
And so when you look at prebiotic chemistry, and particularly in light of this issue of unwarranted researcher involvement, that again is not just simply my criticism, but it's criticism that's arising within the origin of life research community. What they're talking about when they talk about unwarranted researcher involvement is that the chemists that are doing these prebiotic studies are functioning hypernaturally. And so by analogy, could this be the means by which God brought about his creative purposes?
All
and
right.
if that's
So
the case, then all the work in prebiotic chemistry is in effect evidence that is experimental empirical evidence that intelligent agency is necessary for the origin of life.
is there a way to distinguish between
That's was going to be my question.
experimentally between hypernatural action of a mind and the natural action of a mindless process?
That was also going to be my question, because I did a video a little while back now on the alleged miracles at in Lourdes, France, where you have like the grotto and people bathe in the grotto, and then some people claim to be healed from whatever sickness, but none of the miracle claims that have been verified, none of the healings are anything that would like. It's not like somebody lost an arm and they came out of the pool and their arm was back, or something like that. It's like, it's stuff that they could have theoretically healed from anyways. And so it's like, well, so the question like in the video poses like, well, there's not really any way to distinguish if in that instance, for example, God did say, or Mary or whoever, did help them heal from whatever it was, or they just did it on their own. Like, how do we, so yeah, to just basically, how do we differentiate
Jackson,
those
I
things?
find your lack of faith in the Mother of God disturbing.
Well, you won't find Camilla's. So
Okay, well there you go.
So
I'll
she
hang
makes
out
up.
with her.
She makes up for me. So there's that.
Yeah. So, again, the question was how would we distinguish between something that was hypernatural?
Yeah, is there
versus
an
just,
experimental way to distinguish them?
Yeah. Yeah, I mean, in a sense, you would have to, it would be probably subjective and intuitive to some degree. So in other words, if I'm running a prebiotic reaction and, let's take as an example, the work that was done initially in the 90s where RNA molecules were assembled on clay surfaces, right? And this was considered to be a really critical insight that suggested how you could actually have RNA molecules assemble in an aqueous environment where the clay has these interstitial layers, and you could accumulate the building blocks of RNA, and the catalytic surfaces on the clay could drive the formation of RNA polymers. Wow, interesting stuff, right? And this could this have happened on the early Earth? Well, and this is a criticism that Robert Shapiro initially brought to bear, and that is, well, these are interesting experiments in the lab, but it's clearly experiments that the success is due to the researcher involvement. Why? Because first of all, you've got to purchase the clay from a particular supplier. You got to treat the clay in the lab to natriate it. You're removing all the other cations except for sodium. And if you don't, the reaction doesn't work. It has to be run in distilled water. You've got to use RNA building blocks that have been chemically activated in order for the reaction to take place. So I don't know how you would quantify that, right, in terms of, is this hypernatural? But it seems intuitive to me that this is probably an example of hypernaturalism.
I mean, in that sort of case, though, like when we just take a scoop of water, right, it's got lots of stuff in it, right, that would necessarily ruin our experiment, things like viruses, bacteria, etc. And obviously none of those things would have been around. Well, viruses might have been around, but bacteria certainly wouldn't have been around at the origin of life. And so it makes sense to me in that regard why we would want to use, I mean, obviously there's going to be other particulate matter, or there would have been other particulate matter in there in like seawater when these sorts of things were happening, but that doesn't really seem to me. I mean, we're talking about like one particular experiment, and you do have to, they are using these to generate sort of a proof of concept, and maybe in the future they might, say, okay, well, it turns out we didn't actually need to use distilled water, for instance. Instead, we could just use seawater or something like that. And I mean, we do see that sort of stuff with like, or we have seen that with like the origin of life research, right? Like the example with like when researchers went back and reanalyzed like the tubes from the like Miller experiment. Now, even though we know now that their idea of the atmosphere was wrong, the proof of concept was that it would produce biomolecules, and it turned out actually produce way more biomolecules than they initially thought. So
yeah, and so
well, go ahead, please.
So my takeaway from that was ultimately it seemed like a no, because once you said, I feel like it would be subjective, to me, okay, let me back up. What that sounds like to me is you do think that certain people individually could be convinced that a mechanism seems more plausibly hypernatural than natural, but that there probably isn't an objective way to do that. And to me, that's one, okay, fine, that's okay. I'm okay with there being things that some people find subjectively convincing and other people don't. That's just how the world works. But it also says to me that we don't actually really have a way to scientifically differentiate these, and that would then just become a philosophical or theological difference between people interested in the question. And I don't want to say I'm not interested in that. I don't have an argument. I don't have a bone to pick with that idea. basically. If you want to say that, like, yeah, some people will come to the conclusion that, in some way this indicates to their intuition that there's a deity behind all of it, I'll say, okay, yeah, probably does. Which is my general position. Like, I'm not someone who's like, no. If you see God behind the, intricate workings of the universe, you're just being a horrible, illogical, dumb person. Like, that's not my position. If that's something that you find subjectively interesting, okay, fine. But the question that I'm interested in is, what does that mean for science? Does that mean that we should change our research programs in a particular way? Does that mean that there are certain results of certain experiments that now need to be re-examined in the light of the hypernatural option? Because what I'm hearing is it seems like the answer to those is no, at which point I would say, okay, hey, sure, have fun with hypernaturalism as a philosophical idea about how to account for what seem like unlikely outcomes. I find it interesting. I'm not sure it's persuasive for me, but that's great. And I don't know, is there more to it than that?
Well, and maybe my choice of words is subjective and intuitive were probably ill-advised, because, for example, let's use this idea just as a case study, RNA assembly, on clay surfaces, right? I mean, you could potentially put together a table, right? And say, okay, can we run this reaction under any other conditions other than with distilled water? And so if the answer is ultimately no, you have to use distilled water, then the question is distilled water available under the conditions of the early Earth? Yes or no, right? So you might be able to maybe not quantify it, but produce some kind of criteria to say, okay, this really does look like a hypernatural event, right? Or you could even conclude that maybe, RNA materials didn't, assemble using clay as a catalyst as a result of that analysis, right? So, but I think you could probably come up with some kind of objective criteria, but whether or not, I think at the end of the day, you conclude that the line has been crossed between hypernaturalism and naturalism, again, is probably a decision that would be personal, at least as far as I can see. So, so perhaps you do have a point, Dapper, but I think you could, approach it, objectively, because it's. And by the way, we do actually know that you have to run the reaction in distilled water. There have been people that have done those experiments. That's that's a strict criteria. And many of the cationic materials that would have been present in the Earth's, seawater, for example, actually inhibit the reaction. So you have to have, very strict, precise conditions in order for that reaction to run. But so I think there may be ways where you could say the tables lean towards a hypernatural explanation. If this is how you think RNA molecules is formed, then it appears as if it's hypernatural. But the idea of hypernaturalism is it at least, and I've seen people that were skeptics give some, I don't know, gave a positive support for hypernaturalism, in the sense that it's now taking this question of divine action and moving it from this realm in which it can't be studied at all into a realm where, within a materialistic framework of science, you could actually investigate the question of, is there intelligent agency involved, right? This has now become at least something that we could potentially explore scientifically.
I'm not sure how, if you can't find a way to test the hypothesis in an objective way, right? Like, if you can't come up with something like a null hypothesis that you can reject or fail to reject with some kind of test, then how do you investigate it scientifically? All I can see is scientific experiments that, when they seem to have results that are weird or unlikely enough, you can subjectively say, well, that seems hypernaturalistic, which, again, I'm not going to object to. I don't, it does not bother me if you want to come to that conclusion. But if you want to say that this is now a way that we can scientifically investigate intelligent action in things like the origin of life or major transitions in the history of life after its origin, that's the point where I start to say, unless you have a way to test this, to get statistics on it, to have objective criteria, I just don't see how it's going to propose any kind of new research program or alter our conclusions in favor of a God explanation, as opposed to simply saying, yeah, that was really unlikely, but unlikely things happen. And so I can see why it might be intellectually satisfying. I wouldn't even argue that it's not a possibility or that you're wrong to infer it in certain circumstances. I just don't see how it can become a fruitful scientific endeavor without that objective criteria in place.
Yeah. Yeah. Fair point.
Okay, cool. Maybe we agree on that then. Because look,
Okay.
my position or my goal in none of these conversations is ever to make people stop believing in God or general creation or Christianity in particular. I just don't care. My concern is that, as I think you might agree, there's been a rise in the last few decades of the popularity of anti-science in a lot of fields, right? Whether it be biology, medicine, even physics, astronomy, climatology.
Times ahead on that one.
Right. There's a lot of people who are just willing to believe anything that goes against the quote unquote scientific consensus. And that concerns me. What doesn't concern me is if someone says that, like, they think general creation is true, or they think that, you know, Jesus is the incarnate second person of the Holy Trinity, and that his death on the cross affected salvation through whatever metaphor you would prefer, whether it be, you know, substitutionary penal atonement, whether it be Christus Victor, or whatever. Like, none of that is a conversation that I'm interested in as the Dapper Dinosaur in having. That's all fine by me. So if what you're saying is, ultimately, I don't know that it's scientific that we could conclude that there's hypernatural creation events going on, but I find it plausible to think that philosophically in certain circumstances. At that point, I'd say, okay, yeah, fine. I'm good. So Are we actually at that point where we can just say, yeah, okay, that's fine?
Yeah, well, and, you know, and I would see that, you know, as a result of this conversation, this has been extremely helpful for me just to understand, you know, what your objections are, Jackson's objections are to the argument, because it now gives me fodder to go back and start thinking about, are there ways to make this, you know, something that could fall within the realm of science or be properly considered science. But this is something that I think, and I'm not necessarily saying you and Jackson are in this camp, but that a lot of times what people fail to recognize is that when, as a Christian apologist, when I'm engaged in what you might call scientific apologetics, it's really not a scientific argument that I'm making. It's really a philosophical / theological argument that I'm making that's being informed by science. So I will be the first to admit that. It makes people uncomfortable, because I think there are people that want to say, look, there's very clear scientific evidence that indicates that God exists, or that God is playing a role as creator. And I think for some of the reasons that you're raising, that probably is an overstatement, to say the least. But yes, I do think that we can say, here's a philosophical argument. The design argument is a philosophical argument, and that it's informed by science. And so therefore, that this could become a reason why somebody might choose to believe that there is a creator and that it's the God of the Bible, but it doesn't mean that it's a sign. What you're doing here is compelling people scientifically. And when you're making a watchmaker argument too, you're making an inductive argument. You're not making a deductive argument. So it doesn't have that logical certainty that compels a conclusion, but rather it's a probabilistic argument that you're making, where you're saying there's probably a creator, right? It's reasonable to think there's a creator, right? That when you look at the information, the nature of biochemical information, and you see these remarkable similarities with the way in which we structure information and manipulate information that's becoming more and more clear as we invent information technology, that it's reasonable to think that there's a mind behind it. That really is a philosophical or theological conclusion.
Okay.
So I think we're in effect on the same page.
Now,
Right?
this isn't a disagreement. This is just a question. Do you see why that might not be compelling to other people who see that similar types of information seem to arise in different circumstances without the interference of a mind, and therefore it does not seem like a logical leap to think that while we might not know all the mechanisms for it to happen in a different instance, that the fact that it's possible in some instances means that there's no particular need to invoke a new entity into like the operation of this whole thing, in specifically God, in order to explain that, and why that people might take that position as being what they find subjectively more convincing or more plausible.
Oh yeah, I mean that's the nature of argumentation, right? Is that you're presenting a case, and some people may find that case persuasive, and others may not, and that there could be very reasonable explanations for why somebody may not find an argument compelling, but likewise, there are people that do find the argument compelling, are going to see it compelling for maybe different types of reasons, right? So, that's the nature of argumentation, and that's the nature of apologetics.
Okay.
And at the end of the day, my ultimate objective is to say, look, is it reasonable to think that there is a creator that's responsible for the origin and the design of life in light of what we know scientifically? And I think the answer is yes. And if that's the answer that we come to, then I think I would say that I've done my job. But to say that there's going to be, absolute certainty that there must be a creator that's responsible, I think is I think it's bad theology to begin with, and bad philosophy, let alone bad science. So I think we're in agreement there.
It does seem so, but at the risk of turning this all the way back to the very beginning, it seems to me like that is a very different kind of argument that you're putting forth now than anything that could be reasonably inferred from the tweet that kind of precipitated this, which on the one hand, I'm glad it did, because I'm happy to have had this conversation. I think it was a good thing for all parties involved. But to me, it just seems like tweeting something like information never comes into being without a mind or something like that, because remember, I don't remember the exact wording. It seems like that's unhelpful rather than helpful, because to me, what that says is a very different thing than that, well, I find certain circumstances very unlikely, and therefore I intuit a hypernatural explanation in which God uses natural forces to contrive his ends in a way that does not violate any laws of nature, but that are still, somewhat unexpected. And that's a very different conclusion than what I think anyone could reasonably draw from information never comes about without a mind.
Yeah, but I don't think it's wrong to say information comes from a mind.
Well, no,
right?
That's certainly true, because we see minds generating information all the time, unless of course you're a solipsist, in which case, I don't know, maybe you don't see that. I'm not a solipsist. I feel like you're probably not either. So sure, yeah, I think it seems relatively obvious that minds create information. I don't think anyone has ever really disagreed there. The question then becomes like, what is the use of putting out as a pithy statement that nothing but minds can do this, when it doesn't seem like that's even your position?
Yeah. I don't remember what the tweet was either. So,
and yeah, maybe I'm remembering it more.
Yeah, because
I don't more extreme form than it actually had. I don't know.
Yeah, because I'm not sure that I would have said it in the way that you described it. I most likely.
I do remember having someone say that it seemed like what you were doing was satirical because of how absurd it seemed, and the reason that I seem to agree with that, because I do remember that's something that happened, is I responded in support of that, was because we obviously see mindless processes generating information all the time, and so saying that that isn't a thing seems like satire because of how obviously wrong it is. And so I'm sure that I was
can
being
remember that
less
conversation now.
yeah. I'm sure I was being less charitable than possible, and I'm sure that you were being less careful with your tweet than possible. But still, it just seems to me like it's a maybe I wish there were an easier way for you to express that in the form of 200 or so characters, right? Because it's a fairly nuanced claim, and I think it's a weaker claim than what it seemed like you were making. And so, yeah, I don't know. Maybe that's something else to think about is what is a way that you could say that doesn't get that response? Because to me, that response from you, I was a little bit surprised from it, because to me, I thought I didn't think that that's the kind of thing that Fuzz would say, because I generally have a higher opinion of you than that, which is one of the reasons I wanted to have this conversation, because part of me was like, have I just gotten this guy wrong the whole time? I disagree with him on a fair few things, but I don't feel like he's just that silly. And so I'm glad to hear that it doesn't seem like you're as silly as what I was inferring there. So that's good at least. Because your book, I said, you have some good books out there that I've recommended to people. So
I appreciate that feedback, and I'll be more careful as to what
and look, it's Twitter. I've described Twitter, and I stand by this, as it's basically just the bathroom stall wall of the internet. No one cares about your spelling. No one's really there for subtlety. People are just scrawling their current thoughts in the same way that you might find on a stall in the men's room, right? In fact, there's even a fair few places where I would say this is basically the same thing as call Becky for a good time, because there's a few of those accounts too.
Yeah.
So, I get that.
But in the challenge is, how do you be provocative without being
Well, that's actually a question in itself. What are you trying to provoke? Because my interaction, I don't have very many interactions with you, but I'm an not infrequent lurker on the Twitter interactions that you do have, because since I've interacted enough with your posts or people responding to your posts, my algorithm has said, oh, hey, this guy wants to see Fuzz's posts. So I see them. And my general reaction is usually either sort of a bland agreement with it seems like a pretty reasonable take, which is usually the case when you talk about things like the age of the Earth or astronomy or things like that. And then occasionally I'm just kind of befuddled, which is what this was, except it was more than normal. So what are you trying to provoke?
Well, I would just say provoke thought, provoke a reaction.
Oh, you definitely did that. I'll give you that.
Right.
Well, in that case, then, hey, maybe you're doing exactly what you should be in that case, and saying things that maybe you don't technically believe, but that are close and that will provoke opportunities to have a discussion. So I guess what I would be most interested in is if there's a way that we could find some way to do an experiment about hypernaturalism, right? Because I do find it an interesting idea. I do find it hard to say that an omnipotent entity, if it existed, couldn't simply arrange the world such that what it wanted to have happen would happen as a result of natural law, right? Sort of like if you pick your own seed in Minecraft, right? You're like, oh, I know this seed is going to get me what I want, right? Oh, this one has an activated ender portal right where I want it, so I'm going to put that seed in, and there you go. I'm going to beat the game real fast. And that's the kind of thing God could do, right? It's essentially he has a set seed in mind when he's creating the universe. Okay, that seems like a thing that could be plausible, but I don't know how to go from that to anything that we could say, well, therefore what for science? Is there a therefore what?
Yeah, well, I think that's an interesting question. Because I've always thought of the idea of hypernaturalism more in the context of the mode of divine action, more so than how would you actually go about incorporating this into a scientific program.
Right.
But I think it might be worth thinking about, right?
Sorry. The reason I ask is because it seems like in your in interviews I've heard from you or your interactions on Twitter, Like you would like to see a change in how science talks about the origin of life and evolution. It seems like you're not happy with how that discussion is currently going within the academic fields of like evolutionary biology or origin of life research or biochemistry. And so I don't see how you could, like, what change do you want? Does it involve hypernaturalism? And if it does or doesn't, how do you justify getting people on board with that?
Yeah. Well, I mean, I think that there could very well be a place in science to recognize the work of intelligent agency, if indeed intelligent agency is, which I believe is the case, is responsible for the origin and the design and the history of life. And so there are scientific disciplines in which intelligent agency is something that you're probing, right?
Right.
So for example, SETI is predicated on this ability to detect, signals from space that originate from intelligent civilizations and distinguish it from natural processes. So I've actually given some thought and study to what is the criteria that SETI is using to draw that conclusion, and then can we apply that criteria to, let's say, the nature of biochemical systems, right, as an example. And so I think there's a place in a broader sense for appeal to intelligent agency to be part of science, right?
I mean, I would argue that it already is, and that there are just certain areas of science where we haven't found a necessary need to include intelligent processes, right? Like, no one's going to go around saying that, like, I don't know, like psychology or anthropology should ignore intelligent agency, right? Because it's full of intelligent agents doing things. Similarly, I do think that we can find ways to come up with ways to say that a signal from space is unambiguously not natural, or at least with little ambiguity, not natural, and is a result of an intentional broadcast of some kind. But I don't see where that is in biology or biochemistry, other than you just saying, well, this seems unlikely, which, okay, that doesn't seem compelling to me, or like it suggests any new avenue of research or a reason to alter the methodology of current research. So that's what I'm wondering is, like, let's zoom in on, say, biology or biochemistry and origin of life. What kinds of new experiments would you like there to be, or what kinds of experiments that are currently ongoing would you like to have shift in methodology? And if you want current things to shift in methodology, how? Like, what is the actual change that you want to see in origin of life and evolutionary biology?
Yeah, well, to me, I don't know that I would say that there needs to be, and let's just stick with origin of life research. So I don't know that there's necessarily a change in methodology that I would be calling for, but I would argue that there should be a willingness to say perhaps there is an intelligent agent that is responsible for the origin of life. And when I've interacted with some origin of life researchers on this point, their response is that, well, if that's the case, then if you conclude that God did it, then it means that there's nothing left for scientists to do. It's, the whole scientific enterprise is shut down when it comes to the origin of life question. And my response is always, well, that's not the case. You're just going to be asking a different set of questions about, how did God do this? And what was the process that took place? And this is where hypernaturalism plays a role. But I would argue that when you look at the area of prebiotic chemistry, that's an area in which intelligent agents are actively at work, right?
But what I'm not hearing is a way to figure that out, right?
Right. Well, and I agree that I agree in the sense that I've not given adequate thought to how you might go about doing that. And that's something that, as a result of our conversation, I'll probably go off and think about to a much greater degree.
If you write a book about that, I want to thank you in the acknowledgments.
There we go.
I want to see Dapper Dinosaur in that box.
Happy to do that. You know,
You
well, I
actually
mean,
don't have a reliable-
there are a lot of articles or even, you know, things that I do that are inspired by these kind of conversations,
yeah.
right? So I take these conversations seriously and think about this. I mean, is hypernaturalism something that could be objectively evaluated? You know, it might even be fun to go back to Dan Dyke and Hugh Henry and ask them that question and be curious to see how they would go about answering it, since they're the ones that are the originators of the idea and maybe they've given thought to that. So no, so I appreciate that point, but I think again the fact that, you know, when we look at, you know, organic reactions that are, or organic, the work that's going on in organic chemistry as an example, right? You know, their intelligent agents are manipulating nature, and in fact, people are willing to take all the, you know, credit for their ingenuity in terms of figuring out how to run certain reactions that nobody thought could be possibly run. That, so there's an
Right.
area where ingenuity is celebrated, and functionally prebiotic chemistry is essentially a version of, or a subset of, or, you know, work in organic chemistry.
That
You know,
still
another
to me
place,
feels like you're saying because experiments have to be designed, therefore natural processes themselves also have to be designed, and I don't think that that is a valid argument.
no, well, what I would say is because we're designing organic reactions, it very well could be, and we're manipulating nature hypernaturally when we do that. That very could it be that this is exactly how the origin of life originates. Now, another place where I think that reinforces the argument that I'm making would be work in synthetic biology, where people are trying to make artificial cells, particularly from the bottom up. I mean, that's a very interesting area where you see a lot of crosstalk with work in synthetic biology and origin of life research. And it's very clear when you look at the work that people do. There's a study I like to talk about that was published in 2015 by a Japanese team, where they created these protocells that could grow and fissure, and they could also get DNA to replicate inside the protocells, and they could couple the growth and the fissure of the protocells with the growth and division of DNA. So it's just, you know, science at its very best when you look at this type of work, right? But when you look at the level of ingenuity and the manipulation in the lab that's required to execute this, I mean, this is an example of hypernaturalism that seems to suggest, at least by analogy, that maybe the origin of protocells on the early Earth would have required that kind of, you know,
See,
that kind of
I don't follow that, right? Because to me, no matter how ingenious it is, it has to, no matter how ingenious an experiment is that results in a human doing a thing, that in no way to me indicates that therefore that thing can't occur without an intelligent input. And like, say gem growth is an example, right? It takes a lot, and it took a lot of ingenuity and engineering know-how and cleverness and increases in technology to get to the point where we could do things like grow artificial sapphires. But now we can. And I don't think that the level of ingenuity required in any way indicates that natural sapphires are actually the result of a sapphire god. And similarly, I don't think that the level of ingenuity involved in creating a synthetic cell in any way indicates that therefore there has to be a cell god. And so while I can't rule out a cell god on that basis either, I just don't see the logical connection between it takes humans a lot of work and effort and ingenuity to do X, therefore X must have been done by an intelligent agent. It just doesn't connect for me. It's a non sequitur as far as I can tell.
Yeah. Well, but we do understand mechanistically how sapphires grow in nature. Right now, we don't have any kind of mechanistic understanding of how protocells would assemble and, you know, and be able to, couple DNA replication with the growth and division of the protocells. So that would
Right,
be,
but we also don't really know how tornadoes form, and yet we can form vortexes in air in laboratories to study, like the physics of a vortex in isolation, that doesn't mean that there has to be a tornado god.
Right. But
so I just don't see the logical connection. Sorry.
Yeah, but I think the difference would be, sorry for jumping in. I think that the difference would be that we can observe tornadoes forming without without intelligent agency, right? And again, everything that we've done in terms of trying to understand the genesis of protocells seems to indicate that you're working under, what we might call hypernatural conditions, right? That, my training is in, membrane biochemistry and biophysics. And when you look at the work, for example, that people like David Deemer and Jack Shostak have done in terms of trying to understand the origin of protocells, I mean, you can get, primitive protocells to form from fatty acids, but you have to have, unrealistically high concentrations. You have to do this in distilled water. You've got to have just right chain lengths. You've got to have a just right pH.
Right,
and
but Fuzz,
all
of this is just pointing out the level of ingenuity it takes. And I still don't see why that is an important thing to saying that it couldn't happen naturally because it takes ingenuity. And your point about, we see tornadoes form now, I don't think the fact that we don't currently see a natural process occurring means that it couldn't have occurred in the past. Like, for instance, there's lots of natural processes that don't happen on Earth that we know used to happen on Earth, like the formation of banded iron. The fact that there's no one forming banded iron now, as far as I know, even in a lab, and that it isn't forming now naturally because it can't, that does not then lead me to say, well, therefore there must have been an intelligence making banded iron formations. Just like the fact that currently making a synthetic cell requires a lot of ingenuity doesn't also then lead me to say, well, then there must have been a cell-making agent. And the fact that it's hard to do for us right now does not, I can't figure out a way which it logically links back to, therefore, nature couldn't do it. Because nature has done many, many things that humans can't do. And in many ways that humans have yet to figure out. Right. And so what's frustrating to me is I don't think that the idea of hypernaturalism is just, completely nonsense. I think it's a fine philosophical position if you want it. But to me, it just seems like the most we can say is, therefore, scientists should just continue on as they are, and they can have their own private philosophical interpretations of their science, which is just already the case, right? Like, there are theists involved in origin of life research who basically think, this God just arranged the universe such that this happened, and that was his plan all along. And I just don't see what the implications are for science. And at best, it just seems to me like an argument that says, hey, if you're a theist and you find these ideas from science troublesome, you don't have to, and here's a philosophical reason why, to which I would just say, yeah, that's great. But it seems like reasons to believe as a whole, and you in particular, would like to see changes to the actual operation of origin of life and science, and to some degree, evolutionary biology, because I know that while that's not what you want to talk about today, it is a thing that you have objections to. You're saying things like, objecting to, say, human common ancestry to some degree with other apes, or the prokaryote to eukaryote transition or something like that, right? And so I just don't see what the difference is in the project of science. And so the takeaway that I would have as a researcher, if I were one in this field, would be like, well, that's an interesting idea. I'm just going to go back to doing what I was doing because there's no change in project that I can draw from this.
Yeah. Well, and I'm not, I'm not looking for a change in the way science is done necessarily. I just think that for example, I would say that, first of all, I'm not trying to make a logical, I'm not making a deductive argument, right? So therefore, to your point that something doesn't logically follow, I wouldn't necessarily disagree with that because I'm not making a deductive argument. I'm really making an inductive argument. And again, when you look at the level of ingenuity that's required to create something like protocells that can self-replicate, that at least should open up the possibility that there was intelligent agency involved in the origin of life, and to not allow that as being a possible explanation to me seems to be.
But is
seems
anyone
to be
trying to restrict investigation to that? What it sounds like is you don't have a way to investigate that, and I don't have a way that I can think of to investigate that is not basically just what's going on now. And so I feel like it's not actually being precluded so much as it is just that there's no indication that it's a thing that we can or really need to at this point test for. And if you can't even come up with a way to test for it in the first place, I just don't see what the point of it is, at least in terms of how science should proceed. I'm granting that I can understand the philosophical fulfillment that might bring for someone who is a theist who believes in a general creation. I get that. Not going to complain about that. Not going to argue with it. It seems like to me, you're saying that science isn't doing a thing. And I look around and I don't see how they're not doing that, because unless you have a way for them to do differently, you saying they're not doing the thing just doesn't mean anything to me. Like, what does that mean that they're not taking this into account if you can't come up with a different way that they should act in order to take it into account?
Well, but I think part of the issue here, well, first of all, again, I'm not looking to reform science. That's not my objective, other than.
Do you see why it seems to me like you are, though?
Yes, I do. And
Okay.
So I'm not looking to reform science in the sense of changing fundamentally how science is done. What I'm arguing is that there should be places where we should be open to the possibility that intelligent agency may have played a role. And I think once you allow that as a hypothesis, there are ways in which you could begin to test that. You could actually pursue that as a lines of investigation. So I think the restrictive nature of science has led to both of us sitting here saying, well, how would you go about testing this? When in fact, I think if you allowed that as a possible explanation, there very well could be tests that could follow from it.
The thing is, I don't see that as something that's actually being actively precluded. It's just that I don't see anyone coming up with a way that you could test it, and therefore no one is, right? Like, if I was very dedicated to saying that there is an invisible elephant in my garage that happens to turn into a gaseous form whenever I enter the garage, which is why I can never feel it, and it's very quiet, and it has a lot of deodorant, which is why I don't ever smell it, and for some reason it doesn't need to eat and it doesn't poop. Okay, great. I can believe that. I can performatively do things that indicate my belief in that, like
about 3 more minutes.
Yeah, tell people about the elephant and whatnot. But what does that actually mean for anyone other than me? And the thing is, I feel like it means nothing to anyone else. And that just seems like what all of this is like, unless we have a way to say, here's a way to say intelligence, yes or no, then we can't really test it. But we do have ways to test various hypotheses about naturalistic chemical processes that can occur that are pre-biologically relevant to the origin of life question. And that's just what's happening. And so it just feels to me like what you're asking for is what's already there. You just don't like that people who are in that field tend not to agree with your philosophy. And I realize that now we're in the risk of going over time, and that seems like me trying to take the last word. So I'm going to shut up for the entire rest of this, other than to say bye to everybody and maybe tell them to subscribe. So
yeah, Dr. Rana, I'll give you the last word, and then I'll play us out.
Yeah. Well, first of all, I don't no last word in that sense, other than just to say thanks for having me, and
of course
enjoyed the conversation, and appreciated the pushback and the challenges that are raised, and it's given me some work to do. So, but again, always appreciate the conversation.
Well, I enjoy and appreciate having you on. Thank you for coming, Dr. Rana, and thank you for coming, Dapper. I also appreciate having you on. And then I'll be on your channel
Tuesday.
Yeah, next Tuesday. So
Tuesday
you guys can
at 6 Pacific, 9 Eastern, I believe.
Yeah, that sounds right. So I'll be over there. You'll catch me on his channel, and we'll be talking about Bad Jackson. So
yes, Bad Jackson. That
yeah.
Damn naughty Jackson. I will say, this is the first conversation I've had on Jackson's channel with a creationist where I did not actually literally need to go up and get a glass of liquor.
That's true, Dr. Rana. You should see some of the other conversations we have on here. They get pretty rough.
Yeah, usually by somewhere between a half an hour and an hour and 15 minutes, I go and get like a whole tumbler full of whiskey with like maybe one ice cube in it. Today, nope.
Well, I'm not sure if I should apologize or.
No, that's a compliment.
That's a good thing.
That's a good thing.
Who was the last? Was it Terry? Was he the last guy we had on? That conversation was also about information. It was very frustrating.
Yeah, I think that was it. And yeah, he refused to give anything that could be a definition, mostly because whenever he gave one, it then just turned into, okay, but here's an example of information doing the thing you say it can't do. It's like, well, that's not really what I meant by information. Like, oh, okay.
Yeah, that was not a fun conversation. So anyway, all right. Well, thank you guys for coming, and thank you everybody in the live chat for watching, and thank you, of course, Peter, for hosting. As always, the show wouldn't exist without you. So thank you everybody for watching, and we will see all of you next time. So bye everybody.
Hey, before you leave, I just want to take a second to thank my patrons and channel members, especially those pledging $20 or above. Benthoven, Thurevara, Tapioca Weasel, Whispers, Elron Teller, Ian Chen, Calvin Brostic von Manen, Landon Knoll, Mabbity Babbity, Sphincter of Doom, Wallace, Edwin M., North Texas Fossils, John Ackerman, and Strawberry Vein. It's because of my channel members and patrons whom you're seeing on screen that this channel can stay afloat. Without you, it would all shut down. If you want to join the team, there's a link to join the channel below this video, and there's a link to join the Patreon in the description. On the Patreon, you can get a 10% discount for pledging annually, and either way, you get early access to virtually all of my scripted videos, often 3 to 5 months before they come out for the general public. Thanks for watching.